Just moments ago, astronomers caught something extraordinary. New images of 3I Atlas, a mysterious visitor racing through our solar system from deep interstellar space. But what they saw wasn't just interesting, it was shocking. This object, 6 kilometers wide, was moving in a way that defied the rules of gravity itself. It was accelerating, but not because of any visible jets, dust, or gas that could explain it. In other words, something real and physical was pushing it. Yet, whatever that something was, it left no trace. And just like that, the familiar laws of physics suddenly seemed incomplete. Now pause for a moment and imagine this. A silent traveler drifting between the planets, moving tens of thousands of kilometers off its expected course, yet surrounded by nothing. No tail, no glow, no debris. How could that even be possible? The implications were staggering, and the deeper astronomers looked, the stranger it became. Back in 2025, the Hubble Space Telescope had locked onto 3I Atlas as it began its approach toward the inner solar system. What it captured was unsettling in its simplicity. Not the majestic tail of a comet, but a cold, compact point of light, sharp and featureless, like a star pretending to be something else. As it crept closer to the sun, scientists braced for the usual spectacle: sunlight heating its surface, jets of vapor bursting forth, dust swirling into a shimmering coma. But no, Atlas stayed eerily smooth and still. Even Hubble's unmatched sensitivity, capable of picking up the faintest traces of gas or dust, revealed nothing. No halo, no outgassing, just silence. Every data point reinforced the same impossible story. Atlas wasn't behaving like a comet at all. Against the bright scatter of stars, it remained crisp and unchanged, as if untouched by the sun's heat. That early baseline, its clean, unaltered appearance, became the scientific anchor for everything to come. Because once the numbers started rolling in, nothing about them would make sense without it. In the world of comet science, this shouldn't happen. A body that size, that close to the sun, should be shedding material like crazy, bright, dramatic, and messy. Yet week after week, image after image, Atlas stubbornly refused to play by those rules. The data collected in July became the calm before the storm, a frozen moment in time that scientists would later revisit again and again as the mystery deepened. It was the quiet before the cosmos whispered, "Watch closely." Then came the numbers, the cold, hard truth behind the enigma. Observatories across the world began charting Atlas's path with laser precision, and something was undeniably off. By early November, the readings showed it was drifting, not a little, but significantly, about 4 arcseconds from where it should have been. At its distance, that meant an 80,000 kilometer displacement in just a month. That's not a minor wobble. That's a cosmic shove. Something or someone was giving this object a push. Calculations confirmed a net acceleration of about 0.02 millimeters per second squared. Small, sure. But over time, that gentle nudge moved the object the equivalent of twice the Earth-Moon distance in only 30 days. And when scientists broke the force down, they found direction, not chaos. Roughly 135 kilometers per day squared radiating outward, and 60 kilometers per day squared shifting sideways. This wasn't random noise, it was organized, purposeful, like a continuous subtle thrust, the kind that would make any physicist's heart skip a beat. Imagine a ball rolling across a table. Smooth, predictable, steady. Now imagine invisible fingers nudging it, ever so slightly, changing its course, one tiny push at a time. That's what 3I Atlas is doing. Night after night, telescopes around the globe are watching as the object veers gracefully, stubbornly off the map we drew for it. Still, its silent journey continued. After looping around the sun, it began to drift outward again, heading toward its next big milestone. On December 19, 2025, it will pass relatively close to Earth, about 167 million miles away, roughly the same distance that separates our planet from the sun. There's no danger in that, but for astronomers, this is a golden opportunity. Telescopes on the ground and in orbit are already lining up, ready to capture every flicker, every data point, every possible clue about what this interstellar wanderer really is. And somewhere, beyond the reach of our understanding, the question lingers in the dark. What could possibly be propelling it? The real challenge now is figuring out what exactly is doing the pushing and why it's so powerful, yet so invisible. Because as of October 30th, 2025, when 3I Atlas swept past the Sun at its closest point, something truly astonishing happened. Absolutely nothing. This was the moment astronomers had been waiting for, the point when heat from the Sun should have ignited activity on its surface, jets of gas, streaming dust, the telltale signs of a living comet. Instead, Atlas stayed eerily calm, compact, and unchanged, as if the Sun's fire simply didn't matter to it. Still, its silent journey continued. After looping around the Sun, it began to drift outward again, heading toward its next big milestone. On December 19, 2025, it will pass relatively close to Earth, about 167 million miles away, roughly the same distance that separates our planet from the Sun. There's no danger in that, but for astronomers, this is a golden opportunity. Telescopes on the ground and in orbit are already lining up, ready to capture every flicker, every data point, every possible clue about what this interstellar wanderer really is. They'll be watching for any hint of change, a puff of dust, a shimmer of gas, anything that might finally reveal a natural explanation for Atlas's strange motion. But if it remains as stubbornly featureless as before, the mystery will only deepen. After this flyby, it'll continue its escape route toward the outer solar system, on course for a March 2026 encounter with Jupiter's immense gravitational field. That moment will mark its final brush with any major planet before it slips away forever into the dark between the stars. For now, the good news is that Atlas poses no threat, no collision risk with either Earth or Jupiter. Every calculation confirms that. The real danger lies not in its trajectory, but in what it's doing to our understanding of how the universe works. Those key dates, October's perihelion, December's Earth approach, and March's pass by Jupiter, are now locked into scientists' calendars. Each one is a checkpoint in a story that feels more like a cosmic investigation than a mere observation campaign. Every passing milestone is a chance to test new theories. Could sunlight itself be driving the acceleration in some unseen way? Or is there something more exotic, something that doesn't fit neatly into any known category? The clock is ticking, and each new measurement brings us closer to the answer, or perhaps to an entirely new set of questions. But the numbers don't lie, and they tell a story that's hard to ignore. To move an object 6 kilometers wide, tens of thousands of kilometers off course in just a month takes an enormous push. The acceleration measured, about 0.02 millimeters per second squared, sounds tiny, almost laughable. Yet when you realize the object weighs an estimated 33 billion tons, that tiny acceleration demands a staggering amount of energy. Under normal circumstances, the only natural explanation would be outgassing, jets of vapor and dust exploding from beneath the surface like rocket exhaust. But here's where the math slams the door shut. To create that much thrust, Atlas would need to blow off 1/6 of its entire mass in just a few weeks, about 5.5 billion tons of material. That's more than most comets lose over their entire lifetimes. And something like that, you'd see it. Bright, chaotic, impossible to miss. Yet 3I Atlas remains silent and pristine. No glow, no debris, no trace of what's propelling it. Just a cold, steady force pushing it away from everything we thought we understood. And as it drifts farther into the dark, one question refuses to fade. What kind of traveler passes through our solar system and rewrites the rules as it goes? If 3I Atlas were truly behaving like a normal comet, the sky should be putting on a show by now. When a comet vents material at the rate the numbers demand, it doesn't whisper, it roars. You'd see a brilliant, expanding coma, and a sweeping tail of dust stretching millions of kilometers across space, visible even through amateur telescopes. Astronomers are experts at spotting even the faintest hints of gas or debris, a molecule here, a scattering of light there. But if Atlas is truly shedding billions of tons, there should be no mystery at all. The proof would be blindingly obvious: a glowing halo, a spike in brightness, a spectrum bursting with molecular signatures. And yet, nothing. The sky remains utterly silent. That silence isn't just puzzling, it's damning for our understanding. Because if the standard outgassing theory is correct, the next observations must show Atlas erupting with energy. If they don't, then cometary physics as we know it will be facing a serious credibility crisis. And so, the scientific world is mobilizing. Across continents and time zones, a global network of observatories is coming together, determined to find out what's really happening with this strange interstellar visitor. From late November 2025 through January 2026, an unprecedented observation campaign will lock onto 3I Atlas. The James Webb Space Telescope is dedicating precious hours of infrared observation time to peer deeper than ever before, searching for even the faintest wisp of gas or dust. Hubble, still a trusted veteran, will continue snapping razor-sharp images to check for any hint of a growing halo. Meanwhile, on the ground, the world's biggest observatories, Keck, VLT, Subaru, Gemini, and dozens of smaller scopes, will work in shifts, each playing a part in this cosmic stakeout. Photometry will measure its brightness patterns. Spectroscopy will hunt for the spectral fingerprints of familiar cometary gases like water vapor, carbon monoxide, and rarer molecules that could explain its drift. Even polarimetry experts are joining in, studying how sunlight scatters off any dust that might be there, hoping to confirm a strange polarization pattern hinted at in early reports. Behind the scenes, teams are running simulations, tuning their instruments to maximum sensitivity, setting up automated systems that can flag even the faintest anomaly in real time. Every observation counts because the window is painfully short. Atlas will be at its closest to Earth on December 19, 2025, and every clear night between now and then is gold. If Atlas so much as sneezes, if a single puff of gas escapes its surface, the world's instruments are ready to catch it, and if it stays silent, that silence will speak louder than anything else. But the data already collected is painting a very different picture, one that's both mesmerizing and maddening. As Atlas approached the sun, scientists expected its brightness to follow a familiar pattern, gradually increasing as sunlight heated its surface. Instead, the object's light curve went wild. The increase in brightness followed an R to the negative 7.5 law, an insanely steep slope compared to the gentle R to the negative 2 or R to the negative 3 that most comets exhibit. To put it simply, Atlas brightened 10 times faster than any ordinary comet, yet somehow did not erupt into a cloud of gas and dust. It's not a statistical fluke. Multiple observatories working independently confirmed the same pattern. No known comet in modern observation history has brightened this sharply without visibly disintegrating or forming a vast coma. And as if that weren't strange enough, there's the color. Near perihelion, Atlas began to shift toward the blue end of the spectrum. That's the opposite of what happens with typical comets, which glow warm and reddish as their dust scatters sunlight. Blue implies something different, maybe very hot gas emissions or an unusually reflective surface composition. But neither explanation fits the fact that no coma, no gas, no dust has been detected at all. The blue hue has been confirmed by both ground-based telescopes and space-based instruments, ruling out any calibration errors or atmospheric distortion. It's real, it's persistent, and it doesn't behave like anything cometary. So here we are, standing at the edge of understanding, staring at a silent, accelerating, color-shifting interstellar traveler that refuses to obey the rules of nature as we know them. Whatever 3I Atlas is, It's not behaving like a comet. And if the coming months confirm that silence persists, the universe may have just handed us a riddle written in starlight, one that could rewrite the story of what drifts between the stars. The deeper astronomers look, the stranger 3I Atlas becomes. Its steep R minus 7.5 brightening curve and that eerie blue shift near perihelion, especially in the total absence of a dust coma, don't just stretch current comet models, they snap them. The data itself has become a kind of silent testimony. Whatever is changing in Atlas's brightness and color, it's not behaving like any comet we've ever known. With every new observation, the gap between what science expects and what nature delivers grows wider. Each anomaly adds another brick to an impossible wall, and at this point there are 9 of them stacked high against the standard comet rulebook. First, there's the orbit. Atlas arrived almost perfectly aligned with the plane of the solar system, a cosmic coincidence so rare it's statistically off the charts for any random interstellar object. Then came reports of a jet pointed toward the sun instead of away from it, an outright defiance of how solar heating usually triggers outgassing. The object itself is massive, nearly 6 kilometers wide, and moving faster than interstellar ejection models predict for something of its size. Even its planetary encounters seem suspiciously neat. Its close passes with Mars, Venus, and Jupiter cluster tightly together in time, while Earth's view was conveniently blocked right at perihelion. None of this fits the messy randomness expected of natural solar system traffic. Then there's the composition. Spectroscopic data show an abnormally high nickel-to-iron ratio, far beyond what's seen in any known comet or asteroid. And most shocking of all, water, the lifeblood of any comet, is almost missing, just 4% by mass instead of the usual 50% or more. Light reflected from Atlas reveals yet another clue, a polarization pattern that matches no known cometary dust. And to top it all off, its arrival direction aligns uncannily close to the patch of sky where the mysterious 1977 WOW signal was first detected. Finally, that blue perihelion color, cold, unnatural, defiant. Individually, you might explain each of these away. Together, they form a mosaic that refuses to fit the frame. Something about Atlas feels different, something that challenges what we think we know about nature itself. At the forefront of this debate stands Avi Loeb, a Harvard astrophysicist known for his fearless insistence on evidence over comfort. His approach is refreshingly simple. Treat the data as a checklist, not a puzzle forced into a convenient narrative. He doesn't leap to extraordinary claims, but he refuses to ignore extraordinary facts. When a comet accelerates without a coma, he asks, does the push match outgassing physics or not? If a jet points toward the sun, why? If the nickel-to-iron ratio is off the charts, or the orbit seems too neatly aligned, does any known mechanism explain it? For Loeb, it's not about chasing aliens or headlines. It's about science done right, letting the observations lead the theory, not the other way around. His checklist is built on falsifiable criteria, a series of clear decision points. If Atlas develops a coma of measurable brightness, above 20 magnitudes per square arcsecond spreading over 10,000 kilometers or more, then the natural model stands. If spectroscopy picks up strong emission lines from water vapor, carbon monoxide, or other volatiles at rates near 10 to the 29th power molecules per second, then we're looking at a comet, plain and simple. But if the sky stays quiet, no coma, no gas, no dust at the expected levels, then nature itself will have spoken. Outgassing cannot explain the push. The outcome will be binary, as stark as science gets. By January 2026, the data will be in. And this time, there will be no room for interpretation or wishful thinking. Either Atlas behaves like a comet, or it doesn't. This is more than an astronomical event. It's a test of how science handles the unknown, a test of whether we trust the evidence or retreat into familiarity. As telescopes across the world lock onto Atlas, the universe is asking a quiet but profound question. Will we follow the data wherever it leads, or will we turn away because the truth feels too strange? In the coming weeks, one of two voices will emerge: nature or technology. The real frontier isn't out there among the stars, it's in how we choose to listen,